Good.
Hello everyone and welcome again to Koding and Kotlin. KorGE, I'm Pasha and it's Igor with me.
Hello.
Let's reiterate what we did the last time. We implemented some kind of collisions on our gas particles, and just to remind you, we are going to implement an ideal gas simulation at some point. It requires some more work. It requires better collisions and so on. And maybe we should show our current results. How do you think?
Yeah. So right now the collisions are not working as we expect naturally. So this is the example that we have, and the balls just
it
collide.
actually proves that they do not work correctly. Also, we have this bug when balls are stuck in the borders. But actually, when balls hit this way, one of them should go to the right, or to the right, and second should go to the left, like this. And we didn't implement it correctly. We thought that maybe we can use two one-dimensional collisions to calculate the correct two-dimensional collision, but it's not the case actually. Physics is a little
it's just that we tend to think about circles in a different way than the way that the way we implement it.
Like the physical points or what?
Yeah, we need to account for point of contact and some other things, and for that we should use this particular formula.
Okay, what's going here?
So this is the formula for
it's two coordinates, right? Of like velocity is a vector of two coordinates, and it's formula for two coordinates of this velocity, right? After the collision.
Yeah. So v1 prime is the velocity after the collision, and its velocity that was in the beginning minus this particular guy, which is a construction of, you can see that there's a coefficient about masses, and then there is a dot product of difference between velocities and centers. So x is the coordinate of the center. And then here you just subtract it and basically make sure that the, what's it called, dimensions are right, and then that's why you multiply by all the different things. So technically it's just a displacement vector divided by some.
What is it actually? What is this double pipe? I know what modula is.
That's it. That's a measure of distance.
Oh, I see. Squared. Yeah, obviously squared as everything in 2D space.
Yeah.
So okay, let's try to implement. Looks not that hard actually.
Yeah, and actually we are lucky because we know the coordinates of everything, and that's why we can use this formula. And if we were not, we would have to use this one, which is much more involved and requires us to calculate a lot of angles. But
yeah, it's not that hard actually, but yeah.
It's just too many things to code. This one should be easier, but
much easier.
We need to make the dot product first, and for that, let's go back to different window layout. Yeah, to our velocity vector here, and we want to do the velocity dot product. So it's like not operator. Can you have an operator like this in Kotlin? Oh, sorry.
I don't see what that. Like at operator? No.
Yeah, I want to multiply v1 at v2 or something like that.
No, you can't. You only have a predefined set of operators to people not invent any new operators. No, it won't be operator fun. It will be just fun. Yeah, you can call it dot. You can actually use something in backticks. But
Backticks?
wait, I mean, dot is a weird name for function, isn't it?
No, it's dot product. It's
Oh, I see.
reasonable.
That's multiplication for matrices.
Yeah. So it's a scalar actually, and it should be double. And you take your x times other x plus your y times other dot y. And that would be it. And this is a definition of dot product. Basically, it's a projection. I think.
Don't you think it makes sense to call this function product and not dot?
No, because for product you would expect vector product is a different beast.
Ah, I see. Okay, it's complex. Okay.
I mean, technically, there's not much sense to make a vector product in two-dimensional case, but we still don't want to. Maybe in the future we will go to three-dimensional space, right?
Okay.
So
yeah, totally. I don't have any idea how would you draw balls in three-dimensional space, but okay.
Yeah, so this is another thing we want to do is have a minus, which is a very simple one when we just say that this is minus, right?
Yes, and yes.
And just minus here. And the complicated part is that we have x, which is, yeah, let's now do this and see how we can code this. So where is the, it's starting to make too much, scrolling too much to find a proper place.
Yeah.
Yeah, annoying. Probably a good hint that we need to do some
refactoring, move something to different files, I see.
Yeah, where is that? Okay, here's, this is the, as I wanted to be named, yeah. Let's actually remember that we want to make plans. 7th session.
Oops, I named the section correctly, it seems.
Yeah. Okay, we want to fix collisions. Count for gas particle centers. All right, so there's me, there's other. I want to track the velocities. I want to have this. Yeah, so let's call this one mu, and it would be 2 times other mass divided by me mass plus other mass, and I will actually need 2 of those, and this one would be me mass, almost like a me. Yeah. This is initial velocity. This is the velocity, initial velocity of the other. And now I want to say that my velocity would be my initial velocity minus mu1 times scary boy times x1 minus x2. Let me explain this. So x1 minus x2, that would be a vector as well, and I'm just thinking if it makes sense to call this velocity and just doesn't care that it's, yeah, it will do, but whatever. The problem is that we call it velocity, but it's not really. I don't like the name velocity.
Why?
Because it has actually nothing to do about velocity. It's just a two-dimensional vector.
We have point to D in KorGE, but why velocity is not two-dimensional vector again?
No, I mean it's two-dimensional vector, but there is nothing in its implementation that hints me that it has to do with velocity. It's just a vector operations. We have normalization, we have multiplication,
addition,
by number, yeah, and then the
product and so on. So what's not here? What's wrong here with it being velocity? Oh, I see.
Just the name.
You can rename it to vector then, because it's a vector.
So let's do that. I would like to call it vector 2. I'm not sure if that's not shadowing anything.
No,
but
I think it shouldn't, because in KorGE classes are named a bit differently.
And then this one I would like to rename to what's the proper length, I guess. Right?
Yes. Now it's like a pure mathematical thing.
Yeah, and your idea was to make sure that everywhere I use it, it will rename to vector 2, and it should just work fine, right?
Yes, but you already put there some code which won't compile.
Whatever.
Okay. Of course it should work correctly.
Let's see. So I'm just checking that everything works and it compiles, and yeah, it works nice.
Yes, especially the stacking part.
Yeah, so now let's get back to writing everything that we need.
Okay, if do I understand correctly that a result of this computation is just a scalar, or it's a vector too?
It's a vector too. Yeah.
Okay.
Oops, what did I open here? Hierarchy.
I don't care. Okay.
So yeah, this is just positions, and we will probably have issues with that, because why it's saying that X is not available?
I don't know. What are the X in this context?
It's a position. Wait, it's it. Right?
Yes.
Yes. Okay.
Wait, I'm not sure. Is it important that X and Y are potentially not in the center of our particle, but in the top left corner?
Well, it would look strange if we don't do it properly. No, wait, length. Squared, actually.
Squared what?
I just need this thing here, length 2, which will be just this. Right?
Yes, but it's crazy naming. Wait, yeah. Is it even correct? Your length squared is sum of square of your how do you call it? Projections?
Yeah, but here I want to do like this. So it's fine.
Okay. Is it fine? Why is it fine? What's going on here? Why?
I'm just implementing this particular
Yes,
fraction.
I mean, why length 2 is actually a sum of squares of projections? Could you please navigate to length 2 implementation?
How do I split the view into parts?
Split what? Ah, yeah,
Like
you
comma
can just,
SP in Vim.
what? Could you
If I
repeat?
go in Vim, I do like this.
Oh,
and
I
have-
see, of course. You can just drag and drop tabs. To the left, to the right, to the top, to the bottom, everywhere. Yeah, like this. It actually highlights, yes.
I want to do the same. I want to have the same view inside.
I see. You can just open it. Yeah. Okay.
Okay. So here I have.
Explain how length 2 works.
It's just the length, but squared before taking.
No. What I mean, why is it the length? It's currently a sum of squares of projections. Why is it?
Coordinates? Yeah, it's a squared length of the vector. That's the case.
Ah, I see. Okay.
And what I do here is I create new vector, which is like a displacement.
Yes. And
then
you
I take
square it. Yeah.
But squared. So yeah, that's why. And here I will take f1, and other velocity would be initial velocity times mu2 times, well, f2 times x2 minus x1. And then I need to make the f2, which would be pretty much the same.
You can duplicate the previous line by Ctrl-Z.
Ctrl-Z.
Ctrl-Z, yeah. No, yeah.
I need to be highlighted on the line. Okay. Okay, let's call it like this. u2 minus u1, x2 minus x1. Probably would not matter which direction, but it's a good like check. Why it can highlight in this one? Because it says type mismatch, double required vector. What?
Maybe our multiplication is not transitive. Is it possible that we are trying to multiply non-multiplicable things? Multiplicable.
Yeah, just that we
define times something
Yeah.
by double, vector by double, but we didn't define the double times vector. We can actually define it as an extension function, and it will work.
Let's do that because I'm interested in how you do that. Would you just name it like R?
You will just call it fun. No, you won't put it in here. You will put it inside vector because it doesn't belong to vector. You will put it outside of the vector somewhere, and you will call it fun double dot operator fun double dot times. And like in C++. Wow, man. Okay.
But this is very weird because then the logic is not connected to double, it's connected to my vector. I have no...
It is connected to double externally.
Okay.
Operator fun double dot times. Yeah, in parents you have vector 2.
Like this?
Yes.
Okay.
Now it compiles, and now your multiplication is transitive. I'm not sure if it's transitive. Yeah, it is. No, wait, no, it's not transitive. Commutative. When you can change parts of multiplication, it's with the same result. It's commutative operation, right?
I don't know how that is called in English, but yes, probably it's called like that. The proper way to say is that commutator is 0. But that's not what you want to be mentioning.
Yep. Okay, so you think that now it should work?
Yeah, or I think that it should provide us with different result.
Okay, let's try to. Okay.
Yeah.
Wow, it actually works as expected.
Yeah.
Okay.
Let's remove that
Stuck
sticky wall first, and then let's add more particles. Okay. It didn't bother to check if I want to
change the code in your comments. Yeah, it's actually looks like a bug to me. It should check comments. Did you?
I mean, it looks like nothing really changed that much, but we are pretty sure that it works as expected now. We have a bug with velocity that doesn't get changed much, but the elastic collision is in place, and yeah, you can see that sometimes they get stuck. But yeah, looks realistic.
Yeah, I'm sorry, I had a small disruption in my internet connection.
I haven't noticed that because I was talking to my program.
Yeah, to your audience.
Yeah. Well,
actually, I can't even check if it's realistic because it's too fast.
Let's say that velocities, they all running with the same velocity. But actually now we have different mass, right, for them.
Yes.
And this is just also 5.0.
But wait, so now they have all the same mass, right?
Yeah.
Okay. I would say again that maybe mass should be just a square of the shape.
I mean, it's not fun.
For sure.
Why are they starting in the same position? Because I think I forgot that we want to start. We coded it like this, right? Yeah.
Everything in your program happens because you coded it like this.
Yeah.
Programmed it like this is a better way to say. Lots of commented out code. Probably we should delete it.
Absolutely. Yeah. I mean, what tests do you want to run to?
Yeah. Well,
right.
Do we wanna have unstable radius and mass proportional to this radius somehow? Like,
no.
Currently, it's hard to understand how it should work because we don't know. Now they have all the same mass, right?
Yeah. But we can change that as well.
I would prefer to
Kotlin
understand.
is really hard to navigate.
What did you say?
the code is starting to getting hard to navigate. So
Yes. Wow. Okay. Okay. So when a big particle hits small particle, particle should start moving faster, right?
yeah, that's what I'm seeing at least.
I'm trying to see. Okay. Yeah, it actually works this way. So, do we have an ideal gas simulation?
I mean, technically, it's not an ideal gas because it's something I should have mentioned. I wanted to mention last time that ideal gas is the one where particles don't interact. So it's just flying particles in a box. That's a more correct explanation of what it is.
By the way, can we say if temperature of this gas is growing or going down or remains the same? It remains the same because we don't lose our speed anywhere, right? We preserve.
This is a very, in a sense, complicated question because in order to understand it, you need to define what temperature is.
I was told that temperature is kind of speed of particles inside your matter, and the higher speed is the higher temperature is. Is it correct definition?
It's in some cases correct, but then you can answer your question because do we change velocities in any way?
We change velocities, but I'm not sure if we change. I don't know.
Do we change the speed?
No.
Okay.
We preserve impulse. It doesn't. It means that we don't change the. I don't know how do you say it. Average speed. We change the speed of each particular particle.
From the point of view of if we define temperature like that, we can say that temperature stays roughly the same. And I say roughly because we still have bugs like that poor particle
stuck in the wall,
bottom of the screen. Yeah, that is stuck to the wall, which technically should not be doing that. And it's very sad to see that it's just can't get out.
Okay, but should we fix it? I think that now it's time to fix it. Actually,
it's time to fix it. And how about we actually add some particular number displayed somewhere here, which would be our velocity of or the temperature of the system defined.
Okay. You're dreaming of this thing for a long time. Let's try to implement it.
Yeah. Finally.
By the way, okay, I still have this idea to run the native version because we run the JavaScript version all the time. Oh, no, Java version. Well, I was the person who just mixed Java and JavaScript. Nice. Also, probably we should delete all the comments out code. And the mohaha is just it's still wrong.
Yeah, okay. So now we can say that. Ta-da!
Okay, should we dig into the documentation to understand how will we add some numbers?
Let's do something smaller now. Fix annoying color palette. And the text with temperature.
For all our viewers, we actually just solved the huge issues we were facing during previous 6 episodes. Wrong collisions, and so on. Now it behaves correctly, maybe excepting those small bugs with balls stuck in the wall.
Yeah. Okay, so this one to be renamed handle Oh, sorry. Yeah, like this. And
I actually think handle collisions was better because everything we have is particle. But okay. By the way, for me, I see. Turns out I was watching our stream on Twitch with small delay.
okay, good for you. So this is not something I enjoy seeing because it's a different formatting. How do I reformat all of this file again?
Alt Shift L.
Okay.
But also, no. Wait, you're not using our commit dialog anymore? Actually, I think you can minimize the browser window. Then it will be a little bit more space for the idea.
Yeah, let's do that through commit dialog. Fix.
What? Fix collision logics is not enough for you?
No. Now I want to make it clickbaity.
Okay. Like we found that collisions were working wrong, and you can't imagine what we did.
Yeah.
You won't believe. By the way, I think that in this part where you have all this F1, F2, they're quite scary. Maybe you should add command which states where did you find the algorithm. I would still prefer, of course, to have the variables named exactly the same as in the article, but it doesn't.
There is no variable named F1 or F2.
Yeah, maybe I would. Okay, I don't know what is about. Everything is so cryptic here.
You want to be?
I don't know.
Like this?
I don't know. Well, we actually have a shortcut called Control-N. Control-N.
No, like just look at this. Look at this. You're telling me that this is more readable than the one below.
Nothing here is readable.
Well, I have experience writing scientific code, and that's how we do it.
Okay.
Yeah, I mean it's normal that you define just a lot of intermediate functions or variables.
Okay, I agree. Let's move on. So, are we going to try to implement HUD? HUD.
Yeah. Where should we put it? It should be the funny part about that particular issue is that we will have to define it as a scene part and not gas. What's it called? Gas particle something, right? So that's why
it should be somehow attached to the circle, I believe.
You also said that we want to delete particles from the hash map when we delete them, right?
Yeah, right. Thank you for.
So here we want to.
What's a shortcut?
No.
What a shortcut? It doesn't have shortcut. Otherwise, it would be there. But you can always define your shortcut.
How do I do that?
You go to settings. You find your key map. Settings is Control-Alt-S. File settings.
File settings.
But Ctrl-S, I always prefer shortcuts. I just
Yeah,
don't use.
right. I just want to be sure that it's correct settings. Like came up, right?
Yes. Here you can in search you can just hit anywhere outside of this highlight area. Yeah, like this, and search what you need. Like it's very split. Yeah, split down. Edit at keyboard shortcut. Yeah, right. I'm sorry. It's the
So
issue
what
with.
would happen if I do this? Would it
If
override
you,
this one?
let's try to click OK. I think it will propose you to overwrite. Yeah,
right.
It proposes you to remove the old shortcut.
Okay, this is now at least it is convenient.
Okay.
We want to remove it from what's the name of the hash?
Die. Yeah, I see. Circle to particle. But wait, you should do it inside die, don't you?
Oh, right. You're correct. Inside die.
You can navigate in the bottom screen. You can navigate to the die, or you can Ctrl-0. For me, it's Ctrl-0 at least. Navigate to the symbol, to a symbol. No, it doesn't work for you. Okay, we have different
I don't have
key
zero on
maps.
my keyboard. Yeah.
Oh. And also you have other layout, other key map. I have KDE key map. You can actually hit navigate, and there to symbol, navigate, symbol, Ctrl-Alt-Shift-N in your case. And here die, just start typing die. Yeah, here you go.
Gas.
It was something circle to gas particle. Yeah. Remove. Circle. Yeah. Now we don't have our memory leak or potential memory leak.
Terrible leak of one circle.
Yeah, we actually don't know how much space does it take, memory and so on. Did they hit? I'm not sure if they hit.
Yeah. Look at them go.
Okay.
Right. So what are we doing now? We want to
we wanted to
inside the scene.
Temperature. Oh, nice. How do you measure temperature? Like average speed of all your balls? Okay.
Let's once we get there, we will speak about this. But first, let's just display some text in the scene.
Okay. I will link you a link to how do we work with fonts. I'm not sure if I understand it correctly. In private chat in StreamYard. It was nice, but
oh, come on, I forgot the why? What's the difference?
Docs. Let's not debug your typing abilities right now.
No, it's org, not .com. Okay. Yeah.
I'm not sure what do I see here, but there is an interesting part. You can use text, like lowercase function text, that will print something. And if I understand correctly, it will create a text view. Oh, so okay, nice. And when you click the text view, you get 404 error. You can use bitmap fonts with the text view. Do you see? But when you click it, it doesn't work. Oops.
Nice. Views. Text use. No.
We can try to navigate to text. Also, we can try to search for. Oh, nice. Look, there is KorIM chapter, and inside KorIM there is a vector rendering, and there is text inside. You can find it typing text in your search in documentation. What?
Whole world.
Okay. So we are basically already there.
Yeah.
Why did we define it outside of the scene init? To be able to work
I
with
just
it.
copied from the documentation.
Yeah. So just for you to understand what is late init, it's like a promise that at the time when we will try to call it, it will be initialized with not null value.
Okay. So now I want to know about this one, the text.
Control B again. Wow. What? Where KNM? How did you get here?
I just clicked with control on this one.
Wow, man! I don't even know what it is.
Kotlin native module or something like that.
Oh yeah, maybe. I don't have any idea.
But it's funny because when I hover over it, it just says it shows me something.
Yes. Well, it shows you basically the same.
Really? Okay.
Yeah, it just shows you arguments.
Yeah, right. Text size, color, font, alignment.
Yeah.
Render.
Alignment is chaotic evil right now.
Yes, definitely.
Time for nerdy jokes.
Yeah, so what I usually do in this case is just go to GitHub and search for advanced search. What's the name? With this file extensions. Oh, with this
written in language Kotlin.
Yeah, and with this extension .kt, just in case.
It's basically the same.
And I want to see search. I want to see KorGE there as well. And then just check how someone else implemented it.
But wait, you already have it. You can just put everything you need there.
No, but I want to be sure that when I want to enter something here, where is location of the text? I don't see it.
It's alignment, I think.
You think so? Okay. Yeah, there's width and height as well. Text view. I know. No, it's not. Alignment.
Wait, you can look for it in the documentation, right?
Yeah. But I also found it here. So text, then there's some argument, and then there's text bounds, and alignment is middle center, not chaotic evil. And yeah, so
what is text bounds?
I guess.
I mean, I do understand that it's actually just bounds of the text, but it already defined them because we saw the text in our scene, right? Oops.
Okay.
Yeah.
Yeah, it used the default options, which I don't like, and I want to be able to modify them. That's why I want to
I see.
Have some rectangle or something. No, it's not. It's not working.
Yeah, you have hate something like 700.
Oh, it's text size. Okay, this would fail.
It's and actually, what's interesting Balls do not hit it. Oh, that's fine, because the filter is the collided object should be circle, right?
Yeah.
Nice.
Okay, do we want to figure out how to move it, or are we happy with this?
What do we have in after completion on text view? Text view dot something. X, Y.
Oh, wow. Okay.
Oh, I think actually after text you can define a block in curly braces. Yeah, again, you need a new line instead of comma. Still, you need a.
Okay.
It
Good.
works. It was simple.
Yeah.
Well, I
And
mean,
then
when you got the logics of framework, these things become a little bit simpler.
Alignment. Then there is text.
Chaotic evil.
There is no chaotic evil. Sorry.
Oops, doesn't compile.
Text alignment.
So
Center.
what is alignment in our context? Center to what? Center
To the block.
To its
I guess.
bounds.
Yeah.
But bounds are not defined, and it means that they are default most probably, and they will be the tight as possible. But yeah, okay, let's check.
I mean, probably we would not notice that, but if we had like, yeah.
Oh,
So-
and now I do understand how it works.
Yeah. Good. And it's basically where the X and Y anchor would be located, right?
Yes. And
Okay, so now we know that this point.
we just understood several concepts at once. What is anchor?
Yeah.
what is text alignment to this anchor, and so on. Now the thing is, we should update. Okay, yeah, okay.
Text
Yes.
equals to like something like that. Yeah. Okay.
Yeah.
So,
it
this-
just changes, right?
yeah. I want to, when I add a particle, I want to, no, wait, not here. When I add particles with space, text is len of
But you
particles.
should put it in the double quotes.
Like this.
Wait, what? What is len? I know it's particles.size, just without additional curly braces. And you have 2 pairs of curly braces, you don't need them.
Do I need the dollar sign?
Yes.
Okay.
Nice. Yes, because it's in the wrong place. But it should be there too, because now
What?
it works. I don't know why, but it works.
No, I because I added it in updater.
But you have your first 20 initial particles without an updater, right? Oh, updater.
I mean, it happens so fast that it updates
Yeah.
straight away.
Yeah, I see.
So what would happen if I have a multi-line here? Would that work, or do I need to specify that it's a multi-line? No. Okay, good. So
I'm actually shocked because usually work with fonts on canvas is extremely overcomplicated. You should align everything manually, and it doesn't have.
That's why you were so scared about this, right?
Yeah.
Okay. Yeah, I think if we actually try to do something like I don't know, particular font and making sure that it's nice and easy to look at, then it would
The
be
font is already nice, I believe, but yeah, we can experiment a bit, of course.
Yeah, I mean, if we try to do it, then it would be hard. So I'm not. Don't be distracted by the illusion of simplicity here. It might
Yeah,
be
but
harder.
actually there is in the documentation there is part where you can find how do you add a new font. It can even be a TTF font. Okay. It was nice. Maximum temperature is 0 degrees.
Yeah, so I'm not sure how to. So if you know the temperature, if you know the velocities, then you can calculate temperature, and there are different ways to do it, depending on the assumed distribution that you have. And typically,
Distribution of what?
Of velocities, but we know all the velocities, so we actually don't really care about that.
Yeah, we don't need distribution. We know exact values.
Yeah.
But wait. Okay.
So I would say that we can say that KT, which is some constant times, it would be a sum of all mv squared divided by 2, and that would be okay. And then if we divide this by k, we will get the temperature. And this would be our estimation of energy in the system. So let's say that we don't want to do it, and we'll just calculate the energy. And then that would be just the sum of all the velocities times mass of
you can actually then you can map particles to particles. We have particles or something here. No, we don't have it. Wait, so you wanna keep your energy inside your gas particle?
Yeah.
Okay. Mass. Velocity is your Nice.
Something like that.
No, because your velocity changes over time, and your energy is calculated once per on the initialization.
Okay. That's interesting to know. Yes.
You can actually omit this column double part. It will understand it from the type. Yes.
But do I need the line break?
You actually don't. You can
Okay.
remove it. It's only a matter of taste. How do you prefer to write things?
So if I don't say get, it will calculate it once. But if I say get, it becomes a property that calculates every time it exists.
Yes.
Okay. And I assume that I can say that something like set, right?
Yes, but then it should be not val but var, and set accepts an argument, and you don't need val energy. It will be getter and setter attached to one variable. But yes, the general idea is this.
Okay, good. So now I want to do something like energy equals to, well, if it was Python, I would say like sum of
it will be something like that. Particles dot map in curly braces. It will be it dot what we have energy. Yes, and dot sum after everything at the end of the line, like this. Now please hit Alt Enter on it.energy part, because it will give you a small hint. Move lambda outside of parents. Like this. That's all. Maybe it should be. Oh, and actually there is some hint on map
2. If I see it correctly, yeah, sum of, nice.
Mhm. Okay.
I constantly forget about these shortcut functions.
Well, that's why you need the idea to help you. Yeah, so we see that the velocity doesn't change much. Let's decrease
But
it one
wait,
second. The energy wouldn't change much because it should not.
yeah, but we can add one more particle and energy should change dramatically.
Yeah.
Because, yeah, like we create
How
something from
do I
nothing.
specify the parameters? So in Python, I would write something like that. And how do I do this here?
Oh, it's interesting. Because I don't remember actually the formatting options. Energy is what? And energy is double.
Mm.
So we need to format it some. Actually, the first answer is what? Yeah. Okay. No, it
Oops.
doesn't work. It doesn't work. P dot format. I don't know. Oh, so they just created an extension function for that. Because actually, wait, what? Oh, strings support printf format, right?
What?
It should be outside of double quotes, I think.
No, I don't want to. I want to use like this. Can this?
Yeah,
be?
yeah. I think. Wait, what? Oh, I see. So it will be in your case. It will be percent dot something. Outside before the dollar sign, right? And
Before
f
the
at
dollar.
the. Yes, because it's a printf line, and then you're formatting this printf line with your input, right? Could you open this Stack Overflow thing, please, again? It's percent dot, yes. Then your expression and then f. But I don't remember your crazy printf things. Doesn't double have overload formatting? Kotlin, double formatting.
Okay, this is useless.
Okay, let's just put this percent dot then dollar our expression f and then format.
What?
Let me post it in the private chat. Curly braces f like this. Yes, and put energy inside curly braces.
Yeah, but where is the
No,
toucan?
yep. Stop it. You're too fast for me. Yeah, then F after curly braces, or maybe not. Yeah, let's put it there, and then dot format after the string. After the string, and then 2.
This is not gonna work at all. Like this doesn't make sense.
Oh, so it's percent. So instead of this energy and dollar thing, it should be actually 2, right?
Something like that?
Yeah, and you don't need a dollar sign then, because you don't have any real and you don't need curly braces too.
Okay, perfect.
Keep bullshitting me.
I don't understand how your printf works.
Okay, so in normal languages, printf would work like that. You would say printf, then there would be like a format, and then you would provide the arguments for that. So something like that.
Okay.
In Python, you can write something like that, energy.toF, and that would work, or rather print. But here it sounds like when you specify energy here, it should be possible to say that, well, it's something that is formatable.
It's actually interesting because it looks like for Kotlin JVM, there is a format call on string that will do exactly what you define. But it doesn't work in multi-platform environment. Let's look for in KorGE documentation. Clock format, KorGE filters, KorM. Yeah, let's read the documentation on that format actually. No. In KorGE, there is a separate implementation of this format because generally format is nice. Let's navigate to it. Maybe it has some documentation. I don't know. Right inside it. Like nothing, right? Wait,
It's
what?
Kotlin one. It's Kotlin collections, iterable, Kotlin.
Wait, not. It's not format. You navigate it not to code params. So yeah, it's actually should work exactly as you defined it, as you described it, but it doesn't.
Okay, is there a way for... You know what? Let's just cast it to int. Is it possible to do it
Yeah, it should be just to int.
like this?
No. Like to int, colon double to int.
Okay, good enough.
It's not, but okay.
It is.
But truly neutral. Wait, what? Why?
I added back the sticky walls, and now we can see how the energy dissipates through the heat exchange with the boundaries of our system.
Oh, nice.
So yeah, now we have temperature going down, and everyone sticking to the walls. But if I add one more crazy particle, it will.
Yeah, it's interesting how fast they start. I don't know, cooling down in the empty space.
Yeah. So when you have them ordered in a particular fashion, and then you have a particular interaction between particles, and of course not in 2 dimensions, but in 3 dimensions, then it's basically material physics. But then you can't really easily visualize what's going on.
How do you visualize 3D things at all?
You don't.
No, well, I mean, there are games in 3D, right?
Yeah, but then you have like multiple projections typically. In physics, you also have a way to transform one 3-dimensional representation to another one when you have like a different symmetry arguments why you're doing that. And you can see that it never goes down to absolute zero.
Yes.
Well, it will, but it takes a long time. And this is also kind of the reason why the heat death of the universe will be very long, and it will not be 0 Kelvin, but very low.
Oh, it was. Did you see this moment when two particles? I don't know.
We still have bugs,
hit each other?
obviously.
Yes.
Yeah, it did again, and it's. I guess when one particle is too big and the other is too small, and then they have like a dance or something like that.
Yeah, we should implement something. It was weird. It was actually very weird, because one particle just passed another particle. It shouldn't do it, like ever. But
Maybe the collision was not.
Yeah, it was like either collision was not detected. Yeah, it looks like collision was not detected. I don't know why. However, when two things collide, we should detect it somehow and push things in, I don't know, different directions. And actually, what's interesting, nothing happens when one particle hits another particle that is stuck into the wall. No, it happens. It's just very slow.
Because the energy is very little, so it doesn't change
very
much.
slow. Yeah. Yeah, now it's very, I don't know, hypnotic thing. I'm just waiting for energy to become 0, but it won't. And when you said about death,
I mean, we cast it to integer, so it will become 0 at some point when it becomes too small.
Oh, we cast it to integer too late, only before printing it on the screen.
Yeah. So
I see. Yeah, you're right. But I think that now they all are very small, but together they are almost 1. They will decrease very, very slow.
Yeah.
And when you said about heat death of universe, does it impose that there are walls of universe?
Yes, obviously. That's what I meant to say.
By the way, you can improve something on this line. I believe it should be times a sign.
Times sign.
Alt enter again. You can just replace your times a sign.
All right.
Alrighty, let's commit it and maybe we will. Okay. Are you out of time? Of course, I'm interested to see it in JavaScript, as usual. Web.
Yeah, I wanted to change that. They don't change colors anymore.
Yes. It's actually a good thing.
They might. Yeah. Okay. Whatever. Let's just. We added some sort of a temperature. Let's just call it energy. And yeah, let's keep this here. So I want to commit all the things. Some warnings, whatever.
Commit and push. Commit and push.
Commit and push. No.
Nothing to push.
Yeah.
And now I don't know how do you push. I see there is a button in toolbar.
Where?
Or like this. In toolbar of idea, there is those green line, green arrow at the top right corner. Yeah.
Okay, I see.
It will, by the way, disappear in the new UI.
Right? Really? Okay.
Yeah.
What? Okay.
Yes, and almost all the buttons will disappear. It will be much simpler.
Would it become text, or it will just become terrible?
It's up to you to decide. I actually like it.
Can I preview it somehow with the new UI?
Yes. I think actually you can find new UI in settings. Appearance on the left part. No. Maybe not here. Maybe appearance, but maybe it didn't land the community version yet. I'm not sure.
Might happen.
I can't see it here. By the way, we just released the new version of our IDs, so probably you can check for updates and update your help.
How do I do that?
Help, check for updates. Help, check for updates. Update.
Okay.
Oh, I see. So yeah, new ID UI is available via settings. And plugin.
Okay.
Kotlin is incompatible with new version of IDEA. I see. This version of Kotlin is incompatible with the new version IDEA. But
Redis support. Yeah.
yes.
Where do you see that about Kotlin? I don't see.
Red line at the bottom. Plugin incompatible with the new build found Kotlin.
Okay.
I think actually Kotlin will work because Kotlin is essentially a part of IDEA right now. What's going on?
It's building. So let's recap what we did.
Yes.
We fixed the collisions.
I'm sorry that Razor wasn't here today, but he would be happy, I hope.
And what else? We added some sort of information
Yeah.
about
We
the
have
system.
some synthetic energy. It's not completely synthetic. It's almost real physics, you guys.
Yeah.
But yeah, because we don't have any real measurements, so it's a bit synthetic. But it works like it could work in some imaginary real world. It even counts masses. It uses masses, right?
Yeah. So it's I mean, it's not really that synthetic. It's a correct way to determine the energy of the system.
Yeah.
It's just
so what about?
We don't account for anything else aside from it.
Okay.
And, that's where the usual funny part comes when you have like interaction between particles, and then your energy becomes much more complicated to calculate.
Why?
Well, because you need to, for example, let's say you have these two or these three particles in the bottom, they will interact with each other, and then you will need to account for their position and changes, and it's becomes tricky that you need to take into account too many things at once.
Sure. Right.
Like right now, they just interact only when they
hit
each other or hit walls, and outside from that, it's just like they just don't care about anything else. But when they have like the fields or something like that, then it's hard.
Okay, did it deploy?
Let's see. Yeah,
it deployed. Do you remember you wanted to check how many particles can Kotlin handle? You have an option right now to hit space multiple times.
Yeah, and I can now that I want to have energy more than 100,000, and it's impossible.
Yeah, it's almost impossible. They're burning out too fast.
Yes.
Like real people.
So yeah, technically around 130.
So it's already a little bit sluggish, right?
Yeah, absolutely. It's
very sluggish. I see.
It's impossible.
It's a slideshow. Okay. We can actually launch a native implementation and to see how it will work with native implementation. Here you are much closer to 100.
Yeah.
It still works fine. How many collisions does it detect per second?
A lot. Well,
it's still okay, right? It's still okay.
Yeah. I mean, there are a lot of particles that are stuck to the walls at this point, so...
Yeah, but you still have lots of collisions between them. So lots of math to do.
Yeah, I mean...
Now it's a little bit... Now it's a little bit sluggish, isn't it?
Just a tiny bit, so let's say... Let's say we can get to 300.
Yeah, now it's interesting part how many we can get in. Well, yeah, now it's very slow.
Okay, and you wanted to compile it differently, right?
Yeah, native thing. Please open Gradle tool window on the right. Mm-hmm. Yeah, there should be something run. Yeah, run, and then run native Linux x64 release. I think we need this one.
Any expectations how long it will take?
Up to several minutes. Did you launch it? You didn't launch it.
No, not yet. Just run like this.
Yes.
Yeah.
Yes. It will take some time to download everything, and then it will recompile everything with LLVM. But still, the code is not that complicated, so maybe it won't take too much time. But I believe it will be much slower than JVM part.
Really? Why?
Yeah. You need some complex ahead of time compilation is complex.
But I mean the actual implementation when it would run faster.
I'm not sure actually. That's why I'm interested to look at it. It could say if it's faster or not. Hypothetically, math should be much faster in like machine code than in pure Kotlin, but I'm not sure. It will be our, I mean, how do you say, на коленке in English? On the lab?
Hodgepodge.
Yeah, on the lab benchmark.
Yeah.
It's linking something, so it's kind of complex process.
Okay. Should we wait here or?
I don't know. Well, let's wait for another 20 seconds and see.
I mean, we can discuss what we want to do next.
It's an interesting question. We can discuss.
Because technically we're done with this situation.
Yeah.
The physics would be the same if we go to three-dimensional case, then basically most of it would be the same. Like the collision would not change at all.
It will change.
No.
Because you will need 3D collision.
Yeah, but then I will need to vector 3, right? But that would be...
Oops.
The formulas would be the same.
Basically, yes, right. And it will be length 3, not length 2.
Yeah.
What did happen? It just failed, right?
Yeah.
Oh, maybe it didn't have enough memory.
Really?
127. Isn't it about not enough memory? I don't remember.
No. So it compiled it, but it can't run it, right?
Yes, looks like that. Okay, we can debug it next time or between the episodes, I don't know. So yes, what we can do next time, we can do several things. First of all, we should fix bugs. They're annoying. At least with walls. Second of all, we can theoretically try to add a small view to each particle, which will show its own speed right now. I don't know if we are interested in it. No, currently, we have only a very basic HUD. The new one will be a little bit more complicated. But generally speaking, our task is accomplished. We can try to implement the solution for three-body problem. Well, solution. We can solve it analytically, as we know, but we can simulate it. Simulation for three-body problem. We already have masses. We already have speeds. We will need to add to simulate gravity, right?
Yeah, I mean, that would be the hard part of calculating energy, because then it would have potential interaction between them.
Yes, and we already know how do they interact, more or less. Still, it's not implemented the best possible way, but it works. For a three-body problem, it should work something like somewhat similar. And then we'll see, because now we have tasks definitely more than for 2 episodes. Platformer, joystick. Oh, joystick.
I mean, I don't understand why would you add joystick here, but yeah.
Yeah, you can change your velocity of your particles by joystick. Why not?
Yeah.
It's a crazy ineffective use of gamepad, but still.
Yeah.
And that's basically all. Thank you all for watching, and see you next time.
Bye.